Hello students, welcome back to Turning Point classes. In this session, I discuss the first level questions from the third chapter of second PUC, that is current electricity. Let us start. The first question is a capacitor of capacitance 2 microfarad is connected as shown. The internal resistance of the cell is 0.5 ohm. The amount of charge in the capacitor is. Now if you observe a circuit, the middle part of the circuit we are given a capacitor. When you connect a steady current coming from a battery like this, there won't be any continuous flow of current through this part. As we learned in the previous chapter, capacitor blocks the direct current. But continuous current flows only through this. Because of voltage across the 2 ohm, here also there exists a voltage across capacitor but not across 10 ohm. So current, when there is a continuous flow of current through resistor, voltage appears V is equal to I into R. Since there is no continuous flow of current through this part, there won't be any potential difference across 10 ohm. Instead, here potential difference appears. Same potential difference whatever you find across 2 ohm, same potential difference will exist across 2 microfarad. That potential difference V is equal to Q is equal to CV. V is equal to Q by C. We use that formula and find out what is the amount of charge on this. First let us find out what is the current. For finding current, we are not supposed to take this 10 ohm resistor. As I said, there won't be any flow of current through 10 ohm continuously. So only 2 ohm resistance is to be considered. So in the middle part, there won't be any flow of steady current. So for the first question, find what is the current. Current is given by E by R plus R. EMF is given as 2.5. External resistance only 2 ohm I take. Internal resistance is given as 0.5. This gives us 2.5 by 2.5 1 ampere current. Now you find out what is the potential difference across 2 ohm. Potential difference V is nothing but current 1 ampere into resistance is 2 ohm. This gives us 2 volt. Once you find the potential difference, same potential difference will be there even across a capacitor. So this is the potential difference even across 2 microfarad. Now we are asked to find out what is the charge. So charge Q is equal to CV. C is nothing but 2 microfarad. Voltage is 2 volt. This gives us 4 microfarad. So this is 2 volt. 4 microcoulomb negative. So 4 microcoulomb is the answer for this question. The second one is the potential difference between A and B in the circuit is apply Kirchhoff's laws. So loop rule. So with sign convention you have to apply. There is a flow of 2 ampere current. We are moving in the direction of current. In the direction of current, whatever the potential difference you get, you take it as a positive. If you are moving through the cell from positive terminal to negative terminal, take that EMF as positive. If you are going through the cell from negative to positive terminal, take that EMF as negative. If I apply this sign convention, for the second question, 2 ampere is flowing through 6 ohm. 2 ampere is flowing through 6 ohm. Therefore, here the potential difference is 12 volt. So here we can get 2 into 6. So I write VAB, potential difference across A and B. This is 12 volt, 2 ampere into 6 ohm is the first one. Next one, this is also a plus. We are going from positive terminal to negative terminal through the cell. That is also 12 volt. Now 2 ampere flows even through 9 ohm. 2 into 9, this is 2 into 9. Here we are going through the cell from negative terminal to positive terminal. Take that one as negative, minus 4 volt. Then 2 ampere flows even through 5 ohm. That is nothing but 2 into 5. Simplify this. So this is nothing but 12. Here we have 1 12 plus 18 minus 4 plus 10. Simplify. 24, 34, 52, minus 4, 48 we get. 48 volt. So this is the answer for this question. Now the third one, the magnitude of I in ampere for the given circuit. So we are given this circuit, 1 ampere current is reaching this node or junction. It splits into various parts. Here we are given 60 ohm, here 15 ohm in series with 5. That gives us a net resistance of 20. Here we have 10 ohm. All three resistors are in parallel. So in parallel combination, voltage is the same. Current I is equal to V by R. Since V is the same, in parallel combination, current is inversely proportional to R. So in parallel, voltage is the same, current is inversely proportional to resistance. How this current gets distributed is a question mark. Let me take I is given here. I will take this one as I1 for me. So how this current of 1 ampere gets divided into 3 parts, that we will find out. So I1 is to I2 is to I3. Let me take I1 is the current through this, though it is marked I here. Here I take it as I2, this one is I3 because there are 3 branches. This is equal to 1 by R1 is to 1 by R2 is 1 by R3. If I simplify this 1 by R1 is nothing but first branch, I take it as 60. Second branch 15 and 5 in series, that gives us 20 is 1 by, the other one is 10. So LCM, if you take 60, multiply each ratio by 60, you get 1 is to 3 is to 6. 1 ampere, we have to divide in the ratio 1 is to 3 is to 6. So that means 1 plus 3 plus 6, 10 parts are there. I1 has got 1 part. So 1 divided by sum of the ratio, that is sum of the parts, 1 plus 3 plus 6, 1 plus 3 plus 6. Current to be divided is 1 ampere current. So if you divide this, you will get 0.1 ampere. So the answer is 0.1 ampere. That is the answer. Coming back to the next question, A and B are 2 bulbs connected in parallel. A is glowing brighter than B. The relation between the resistances of A and B, RA and RB. Already I discussed this. So in parallel connection, the one which has got lower resistance glows brightly. The one which has got higher resistance glows dim. Dim bulbs have high resistance, bright bulbs have low resistance. Here the one which is glowing brighter is A, therefore its resistance must be less. So RA is less than RB or RB is greater than RA. Option B is the answer. Next one, 3 resistances of magnitudes 2, 3, 5. They are connected in parallel with a battery of 9 volt and of negligible internal resistance. Potential difference across the 3 ohm resistors is, when battery has no internal resistance, whatever the potential difference you observe is equal to EMF itself. So the potential difference across all these resistors is equal to EMF of the cell. The EMF here is given as 10 volt. The 10 volt itself is the potential difference across all resistors. So the answer is option D. And the next problem, similar to this, but extra is here the source has got 1 ohm internal resistance. You find out what is the potential difference across 3 ohm resistance. Now this we have to solve it. So in the sixth one, find what is the effective resistance of the 3 resistors connected in parallel, making use of 1 by R is equal to 1 by R1 plus 1 by R2. Here it is 1 by 2 plus 1 by 3 plus 1 by 5. Take LCM. I take 30. Then we get this is 15. So this one is 10 plus this is 6. So that gives us 31 by 30. This is 1 by R. So R is equal to 30 by 31. I take approximately equal to 1 ohm. So this is the effective resistance of the 3 resistors connected in parallel. So you find out what is the current. Current I is equal to EMF divided by external resistance plus internal resistance. EMF is given as 10 volt divided by, now the combination of 3 resistors in parallel has given as 1 ohm resistance plus internal resistance is also given as 1 ohm. This gives us 5 ampere current. Now voltage across the combination, whatever you find, That voltage itself is a voltage across all individual resistors. So voltage V is equal to current into external resistance. So current is 5 ampere, external resistance, effective external resistance is 1 ohm. So therefore you get 5 volt. Approximately 5 volt is the answer. So the voltage across even 3 ohm is also same 5 volt itself. So C is answer of this question. With this I end today's session. If you have not watched my previous videos, link is provided. Go to the link and view previous videos. Subscribe to the Turning Point classes. Share the link with your friends. Like the video. I'll come back with a few more questions in the next class. God bless you.